We've been simplifying roots for quite some time. Number of videos here. Now, what we're going to do is we're going to take this to a next step. So we've added them, multiplied them, divided them. Let's solve equations that involve them. And the secret to this, oh, there's some crazy wording on this screen. I'm not sure what happened there, but the secret to this is always, I don't know if we've seen absolute values yet. Trying to remember what we've covered. When you ever have a difficult portion of an equation like this, you can ignore that, I don't know what language that is. Whenever we have a difficult portion of the equation, we want to treat that as if it's a giant I don't know. Like if this was x, let's get this thing by itself. So what I need to do then to get him alone is I would add 9 to both sides. So that's what they've done here. They've now gotten that problem area, the square root, all by itself by just swinging the 9 to the other side. Now, the trick here is actually quite easy. If you have this alone on one side, the way to get rid of a square root is to square something. And if you do it to one side, however, you've got to do it to the other. So by squaring both sides, I've now eliminated the root altogether, and I have a new equation that's quite simple to solve. So we'll do the same here. We want to isolate this root by sending 5. We are adding 5 to both sides. So I'm left with this. Now, to get rid of a root, we're going to square this side. But if you do it to one side, you got to do it to the other. So we now have 3m plus 2 equals 25. Now, it's just an old school equation. We're going to subtract 2 from each side. I get 3m equals 23. I'm surprised we get a weird fraction, but this is what we would get. Okay, I don't know if anything weird's going to happen here. Yeah. Okay, I find this to be one of the weirdest things in math. It's not explained very well. But so let's look here. So I'm going to do what we just did, where we're going to get this problem portion all by itself, and we get here. Now they're saying that the square root equals -1, and that has no solution. I find this really weird because in the math books, they'll always like jump between when it's allowed to have a negative and when it is not. But so you remember, the question is this: if you take the square root of 9, isn't the answer plus or minus 3? Well, when we're solving these, when they're working with equations, they're going to disregard the negative version of the equation. It has something to do with functions, and I'm trying to think if we've covered the idea, but in order to be a function, we need to get rid of the negative values that come out of this machine, or else it isn't going to work. It's no longer considered a function. I don't know if I've covered that, but that's why they're doing it. And so they call it the positive root. We're just going to take the, what do they call it? The positive principal root. So sometimes we want the plus and minus, and sometimes we don't. But if we're solving equations, we don't. They're going to limit this, and I believe their reasoning is it has to do with functions. We're going to limit this to only be the positive values. Okay? So that one is no solution. Okay, now yeah, I don't think there's anything that, we don't need a trick here. Let's do exactly what we've been doing. I want to get the square root by itself, so I'm going to subtract a 1 from both sides. So now I have this. We isolated the problem. Now we want to square the room on the left, but if you do that, you must also square the room on the right. The only thing that's going to happen here is we're just going to get, we have to FOIL this out. They were showing us the pattern, but if you don't remember the pattern, we're just doing p minus 1 times another p minus 1. Okay, now all of this is here. We have now taken care of the root. We FOILed this out. The only way at this point that we know, at least till the next chapter, to solve something with a p squared in it is that we're going to use the zero product property, which means everything, we need one of the rooms to be 0. Everything is going to come over to the right. So they just moved everything over. So I'm subtracting p here. I'm adding 1 so that they'll go to the other room. Now make sure you combine the right things here. Yeah, sorry, that should have been a minus p. So they just sent that stuff to the other room. Now that room is empty. Okay, the zero product property says if you can factor this stuff over here on the right, like we've done here, either one of these might be the reason this is turning into 0. So we set each of them equal to 0, and then we solve. So we get 2 values. Okay, let's do it again here. We're going to isolate our problem area. We get this. Now we need to square both sides. If I square the left, that's easy. But if I square the right, x minus 2 squared, we could FOIL that out, or if you remember the pattern, it's going to be this. Okay, we need the zero product property, which means let's get a room empty. So I'm going to add 2 to both sides. I'm going to subtract an x from both sides. I'm just emptying this room over here. I get this. Now because of the square, we got to factor this. Oh, that's not. There's 6 is tricky because there's several ways to do it, and that was not the right one. Okay, now we have it factored, so either of these could be the reason this is turning into 0. So I'm going to set them both equal to 0. And my solutions are x is 3 and x is 2. All right, we're doing the exact same thing, but we have a cube root this time. I think you'll see what's happening. We still just need to isolate the problem portion. Now, I've isolated that problem. Now, instead of squaring both sides, however, I'm going to cube both sides. So that will still solve the issue over here, but over here, we're going to get negative 27. So I've cubed negative 3. Okay, from this point, we can just solve. Which is negative 6. Same thing. Do you remember that this means a fourth root? So I'm going to isolate that and get 3x minus 2 all to the 1/4. Send that to the other side. Now that's a fourth root, so if I take this side to the 4th power, that will solve it. But if I do it to one side, I've got to do it to the other. So I don't want to show that. I want this. If I take it to the 4th power, it solves this. But if I take the left to the 4th, I've got to do 2 to the 4th, which would be 16. And we get 6. Okay, try one on your own if you want to pause it. But it's the same thing. We're going to isolate that problem portion. Now it's to the 1/4, so or a fourth root. So we're going to take this to the 4th power. If we do it to this side, we got to do it to this one. And 3 to the 4th. Double checking myself is 81. Oh, that's not right. I don't have my times tables memorized. Okay, now this one is going to be similar. Let me see. Let's see if I can work. Okay. Yeah, they start off the same way I would. We're going to move all of this stuff to the other side. We have 2 things that are problem area. We're going to move them both over. Now, let's square the left and square the right. The left is easy, but to square the right, we just have to FOIL it. And now it's now become what we did before. We're going to make the zero product property, send everybody over. So you're subtracting r, you're subtracting 4, and now if you combine it with the proper stuff on the other side, this is what you get. And I find people have a hard time with this. They're like, I don't know what to do with that. all you got to do is pull out a GCF. This is actually much easier to do. Pull out a GCF and you've got r and r minus 5. Okay, well if either of these equals 0, so if r is 0 or r minus 5 is 0, the whole thing is 0. So our two solutions are r is 5 and r is 0. Now we haven't seen this before, but you should check your answer. We saw this all back with rational expressions, that you would check your values to make sure that you didn't break anything. The same thing can happen here, that sometimes the values that we're creating with these rational equations are not true. So we should check them by putting them back into the original equation and see if it works. So if I put 5 in here, I get something that tells the truth. You tidy that up, you get 0 equals 0. But if you put 0 in, you don't. You get something that doesn't tell the truth. You wind up getting 4, but that doesn't equal 0. So it turned out that we got a false answer here, and r equals 0 is not really true. Our only answer is 5. Okay, much more complicated, but the idea is the same. What we'd want to do to isolate this is we want to imagine all of that square root is a big I don't know. So if I had this, I would add 8 to both sides first, and then I would divide both by 3. That's what we're going to do here. First I send the 8 over to the other side. Now, this is still not alone. It's like 3x. I would divide both sides by 3. Okay, I've done that, and now it turns into something we've seen before. We square both sides. We get just a normal equation. Solve it. You get 7. Okay, feel free to pause and try this. I'm isolating this. So I'm adding 16 to both sides. Now, I'm still not isolated. I'm multiplying this by 2, and I don't want that. So I'm going to divide both sides by 2. Okay, now we're down to something we've seen before. I can square both sides. That takes care of the problem over here. And over on this side, we're going to have to square that. Hold on. I don't want to do that. I'm going to use my calculator. So I get 256. Now we just solve. That's supposed to be a 254. Divide both sides by 4. Oh no, should have been a 2. Sorry, should have been 252. We get A is 63. Okay, this seems very different, but it's really not. I already have the problems isolated on both sides, so all I got to do is cube both sides and it'll turn into something really simple. So the problem things are isolated on both sides. If I cube one side and cube the other, it's going to take care of everything, and all I have is a regular equation. Solve it for x, and it's quite simple. So the same here, I could just cube both sides. I get 5x minus 4 equals 2x plus 5. Just solve it. I'm going to send the x's. You got to get the x's back together, so I'm going to get 3x minus 4 equals 5. So just doing some old school solving here. X is 3. Okay, hold on. I want to see where we're going. So what they're doing here is that we have something that's going to require the trick twice. So do you see here that I can't isolate the root all by itself because I've got one on both rooms. So I've got this one on the right already isolated, so let's just go ahead and square this. Oops. If I do it to one side, I got to do it to the other. So if I square the right, that turns out to be x minus 3. Okay, but this isn't done yet. Okay, so what are we going to do with this? Well, we know how to square this, and you could do it by foiling it out because it's two of the same thing, but it's going to get this. It's going to get this. Now, We still have a root that's left. Well, let's do the same trick we just did. Let's tidy everything up by trying to get him alone. So I'm going to get the x's back together, but if I subtract x from both sides, they're gone. So I'm left with this. I'm going to send the 9 to the other side. Just moving stuff around, just like we learned all the way at the beginning. Now, divide both sides by -6. I get this. Okay, well, we've isolated a second time, but this time if we square one side and square the other, it's going to be our answer. All right, I'd really recommend you try this one because it's very difficult, but I'll show you. I've got one of these already isolated on the right, so I'm just going to go ahead and square this. Yeah, I don't know. Maybe I shouldn't have sent you to try this. I don't know if you did. This would be this is a little different looking, so it's going to be a little confusing. What we've said here is the pattern is you can square the first one, so I'm going to get now x minus 1. You can square the back one, you get 4. And you're going to get this one. I should probably show you this. So I know this looks different, but it's the same thing. There times there would just be x minus 1. There times there would get you 2 square root of x minus 1. And there times there gets you 4. So we tidy this up. These are the names. These are like terms. So you're going to get, hold on, let's do it here. We get, the -1 and the 4 can go together. So I'm going to get, see if you can follow how I tidied this up. That's what I would get. Just put the 4 and the -1, put those together. Okay, so here's what I've got now. X plus 4 square root of x minus 1 plus 3 equals 2x plus 6. Now that wasn't easy, but we're still not done. We have another square root that's still in the problem, so we need to isolate that. I'm going to get the x's back together. I've now got 1x over here. I'm going to subtract 3 from both sides. So I've got x plus 3 over here, and now I have this. Okay, now we got to get rid of the 4. Wow, this is really hard. I hope you didn't try this on your own because this is difficult. So I had to divide away that 4. So this is what I've got. All right, all of that in order to now square both sides. If I square the left, it's easy. Wow, this is way beyond anything we've done before. Over here, I would get that. Now, we send the 1 over to the other side. This one is quite unbelievable, actually. I think it's a little bit beyond our scope here at this point in this book, but we would get all that. Now, we could solve this and keep going, but I think that's the best we're going to be able to do. Oh, no, hold on. Give me just a second. We're not done. I paused this. I'm going to show this to you again if you care. I think this is way beyond the scope of what I would ask you to do. But we're going to do it anyway. I'll show you if you care. If not, you can just move on. I did a step that would work, but is not. I saw what the book did to make this easier. Okay, so I squared both sides. Just going to tidy things up. Okay, this is what I already did. Now I'm going to send the x and the 3 to the other side. I did this before, and I got, so I'm subtracting an x from both sides. I'm subtracting a 3. Okay, so I get this. Now what they did right here, which is actually a little tricky, but they left the 4 here. I can square this right here as it is, and it's going to make it a little easier to do. So I'm going to square both sides. Now you'll get 16 times x minus 1. Okay, now if we square this over here, so we can just FOIL that out. So now over here I've got 16x minus 16 equals x squared plus 6x plus 9. Now we have to get a room equal to 0, so I'm sending all of this stuff over to the right. Now I'm subtracting 16x so he can join up over here. It's got minus 10x. I'm adding 16 to both. I get plus 25. Okay, now I have it all over there, and so now we know how to factor this, and we have to, at least at this point. We don't know any other way. So if you factor that down, you get this. Now we use our zero product property, which is weird because we're doing the same thing. If either of those equals 0, the whole thing is 0. Well, it's the same number, and that's okay. We get x equals 5. So much harder trick. Again, I would not do this to you on a test, but if you're moving on to more advanced math, it might be good to understand. We did the trick twice, and where mine went wrong, I would have gotten there, but it would have been a lot harder. They just left this for, it's easier to just square it right there altogether, and it would get you 16 times x minus 1. And then it turns into a problem like before. Again, awfully hard, and I think it's a little bit beyond our typical scope, but there you go.